Hi, I'm Edward Hofer with Politipeeps, and today we are interviewing Jonathan Grassmick. Hello, Jonathan.
Hi, Edward.
Welcome to the show. How are you doing?
I'm doing fine. How are you?
I am doing just great. So today we're going to talk a little bit about climate change. And recently we spoke with Aga Niviana. She is a climate activist in Greenland, and she's very concerned about the climate. What would you tell her about the climate? How would you talk to her about the climate?
I thought that was a very interesting interview. In Greenland, we're talking about a continent, or it's not a continent, but I mean it's the size of a continent. Or we're talking about a place that is covered in ice, and the very fact that the people that live there are not wanting the ice to melt is a little shocking to me. So I think that I would tell her that, for one thing, I wouldn't be super concerned about all the alarmism about the melting ice. I don't think in her lifetime that it's going to present huge issues. But even if the ice did melt, you're talking about more opportunities to grow your own food and not have to import it from other places. You're talking about being able to, have just warmer weather. It's not the end of the world if there's a little bit of climate change that causes warmer temperatures in Greenland, in my opinion.
Yes, a lot of people seem to think that climate skeptics deny that warming is taking place. Can you explain why they think that and what the truth is?
Yeah, I think that there are some skeptics that maybe think that warming isn't taking place, but I mean I think that it's taking place. But there are different camps as far as what you believe climate change is. If we define terms as what is climate change, I think that you could say that it's just a process that has happened for millions of years. It's always the climate has always changed. I think that when the alarmist community talks about climate change, they're talking about catastrophic climate change, something that is going to really hurt the environment and something that government needs to do major things, take drastic actions to prevent or mitigate. So those are the kind of two definitions of climate change. And if you're talking about my definition, well, yeah, the climate is changing. It always changes.
Okay, well, climate scientists talk about anthropogenic climate change.
Right.
How does anthropogenic climate change differ from just regular climate change, and why is that important?
Yeah, I mean, anthropogenic just basically means that it's human caused. So, and I think that there is an element of human caused climate change. There's a part of the changing climate that you can probably attribute to humans. The question is how much? How much of it is natural and how much of it is caused by humans? We're talking since the Industrial Revolution, the numbers vary between a degree and 1.7 degrees Celsius of temperature rise, in 240 years. A portion of that is probably attributed to added CO2 that humans added to the atmosphere by burning fossil fuels. So, we're talking about maybe somewhere between a degree and 1.7 degrees. To me, that's not alarming.
Okay. There's a website called Skeptic Science where they claim to have debunked all of the climate skeptic claims. Can you address that or respond to that claim?
Yeah, I mean, I'm very familiar with skeptical science, and I think that a lot of times what they do is they don't actually rebut actual arguments by skeptics. I think it's a little funny that they're called skeptical science because I don't think that they're skeptical at all. They seem to be towing the line of the climate alarmists and the governments around the world and not being skeptical like true scientists should be.
Okay, that's a very interesting perspective. One of the big claims that climate activists use is that 97% of scientists agree that climate change is a major problem and will lead to catastrophe. What would you say to somebody who says that there's a broad consensus on climate change?
Well, the first thing I would say is that science is not done by consensus. So it only takes one correct scientist to prove all the other scientists wrong. So that's the first point I would make. The second point is I would question their methods of determining that number. 97%. I mean, did they send out a survey? What did they do to get to that number? So it's a lot more complex than just a yes or no answer. Like I was mentioning earlier, there are two different definitions of climate change. There's a definition that says, yeah, it's a major problem and it's mostly human caused and we must do something about it or else we're doomed. And then there's the definition that says, yeah, it's happening, but a portion of it is human caused, but it might not be all that big of a problem for the human species. So depending on which definition you're talking about, those scientists that are in that 97% may have a view of that somewhere on that spectrum. So they may be including a scientist that does believe in climate change, but maybe doesn't think that it's a big deal. I think that the way they came to that number was by going through all the, or not all of the peer-reviewed articles, but a certain percentage of the peer-reviewed science, and they determined that some were, I guess, for the idea that the climate change is a problem, and some were not. But how big of a problem? How much of it is human caused? There's a lot more questions to be answered in that than just a simple yes or no.
Yes, a simple answer really doesn't give you much information about what's going on. So there's something called the Petition Project. Have you heard of that?
I have, yeah.
Can you tell us a little bit about what that is and what it means?
Sure. It's just a project that collected signatures from scientists around the world that and asked them to sign a statement that said that they don't agree with the prevailing wisdom of climate alarmism, and that climate change is not the big problem that a lot of people say it is. So I think they have collected 31,000 signatures on that.
Oh, that's interesting. The Skeptical Science website says that because their hypotheses have not been disproven, that we should go with the 97% hypothesis. Can you explain what they're saying there and how you feel about it?
I call it the 97% hoax, because it's not really, there's no way you can determine a figure like that with the certainty that they claim. So to say that 97% of scientists believe that climate change, believe in climate change, I mean, what does that really mean? And this kind of goes back to what I was talking about earlier about the definition of climate change. When you say climate change, do you believe that it's a huge problem that governments need to take drastic measures to mitigate against? Or do you think that maybe it's even beneficial? So there's a big spectrum, there's a broad spectrum between those two points of view. And I think that a lot of scientists do fall somewhere on that spectrum. But to say that just because you believe in climate change, you're part of that 97%, I think that's disingenuous at best.
Okay, that's very interesting. Another argument against the climate alarmists is that the models that they have been using are notoriously unpredictable, and that they often contradict each other, and that they're based on current observations and not with a world that actually has an increased percentage of CO2 in the atmosphere.
Yeah, I think that the models have been notoriously inaccurate. There's a really great paper, it's a peer-reviewed study by Patrick Frank in the Frontiers in Earth Science, and it is talking about propagation errors in the climate models. And the point of it is that these climate models do not contain the error bars that most scientific studies do have. And so these climate models they're very complex. And by the time that you propagate the errors in each of the different calculations that they make, they can add up to be quite significant. And so Dr. Frank, he makes a really good case for these climate models being very inaccurate, and you really cannot take what they say as truth. And we can actually see that just in the collected data as well. Dr. Christie at the University of Huntsville has done research on this as well, and they have compared the model projections to the actual collected data in the field, and you'll have a situation where the model predictions are going up like this, and the actual data is down here, and so they don't match up. So there's something strange in there, and there are situations where a model or two might be correct, but it's for the most part they're wildly inaccurate.
Okay, so you mentioned error bars in there. Can you explain briefly what those are and give us a real-world example of why they're important?
Yeah, I mean, error bars basically tell you how confident that you are that that your calculation is correct. So if you think about a standard bell curve, you take measurements of a particular phenomenon. Well, how confident are you that those measurements are going to be within a certain place on that bell curve? So that's basically what it is. And if you're talking about a climate model that's making predictions about the future, so you're doing calculations about lots of different things in this model. So if you calculate the errors for each of these different variables, then you have to add all those up, and that's called error propagation. And so by the time you add all those up, you can get error calculations that give you a degree of confidence that is not very good, and you may have something like, well, where we think that the temperature is going to rise 1.5 degrees in the next 50 years, plus or minus 10 degrees. Well, what does that tell you? It doesn't tell you anything, really. It just tells you that you're not very confident in your data and in your calculations. But these models, according to Dr. Frank, they don't contain these error propagation.
Well, one of the things that the Skeptical Science website says is that many of these models have been accurate in their predictions. How would you respond to them when they say that?
I think that there is a lot of fudging of those numbers. So and there's cherry picking of the numbers too. They'll take the numbers that agree with the models and instead of the numbers that don't. For instance, they will take the land surface data that is collected at weather stations across the world that are known to be fairly inaccurate because of things like heat island effect and just regular old human error and bias. They'll take those numbers, but they won't take the satellite data. And earlier I was talking about John Christie and how he has taken the satellite data and how the satellite data doesn't match up with the models. And if you want to take the satellite data, that's going to be more accurate than those surface temperature data. But they tend to take the ones that match their predictions, and I think that's not really science.
Can you give us a little bit more about the heat effect thing that you mentioned?
Yeah, so you have a weather station that collects different sets of data like wind speed and temperature and precipitation, and over time the conditions around some of these stations can change. And so if you have a weather station on the outskirts of a city, and over time that city grows, what you end up with is a situation where the physical world around that weather station impacts the data that is collected there. So if you have a bunch of concrete that is poured around the weather station, you are going to affect the temperature because that concrete acts as a heat sink. It will absorb the heat during the day from the sun, and then it will emit it at night. And so in several of these places, you end up with nighttime temperatures that are higher than they used to be. And they say that they try to mitigate for that, but there's no way to know for sure how much of an effect it has had. So that's why I say, use the satellite data, because that's going to be much more accurate.
There are some people who say there hasn't been any warming in the last 16 years. Is that a true statement?
I believe it's true, but again, it goes back to which sets of data do you use? Do you use the satellite data, or do you use the land surface data from these weather stations around the world? I think that you should use the satellite data. And if you use the land surface data, I think that there's opportunities for that data to be corrupted, like we were talking about earlier with the heat island effect.
Okay, with that, a lot of climate scientists say that the oceans are absorbing up to 93% of the additional heat, and that's going to put species in the oceans at risk. Is this a true statement?
I don't believe that's a true statement. For one thing, the temperature of the ocean is something that's very hard to determine. You're talking about taking measurements at different locations all over the world at different depths. I think a lot of media coverage of this topic makes it sound like scientists have a really good idea of what the ocean temperature is, but it's just not that simple. And the ocean has been much warmer in the past. We know this. We know that in the distant past, the temperatures have been much higher. So species are adaptable. They are able to adapt to changes in temperature, and there's no reason to believe that they wouldn't be able to adapt to changes in the ocean temperature now.
So the sun's not stalking you anymore in the room you're at now.
No, this is much better.
So down in Australia, we're hearing reports that the Great Barrier Reef is dying and climate change is the culprit. What would you say to people who want to take drastic action to save the Great Barrier Reef?
Well, according to several scientists who study the Great Barrier Reef, it's actually not in danger. It's not in peril. The big issue is that the reef is bleaching. So that's a process where the coral turns white, and then the coral dies. And it is shocking. It's kind of like a forest fire in the Western United States. And I have a lot of experience with fire ecology. I live in New Mexico, and we deal with fire. And in my everyday line of work, that's something that I have to work with. So, and it's the same thing here. The people are really scared of fire and what it does to the ecosystem and the environment, and it looks very scary. What they don't understand is that it's a natural process. And these forests, a lot of them are adapted to fire, and they need it in order to go through the natural process of succession that allows regeneration, and eventually it's a healthy forest again. The coral reef is the same way. It goes through these processes of bleaching. It might get stressed, just like a forest will get stressed because of a drought, and then beetles will come in, bark beetles will come in and kill the trees, and then there'll be a forest fire, and then it'll regenerate. The coral reef is similar. They might get stressed for one reason or another. It may be water temperatures spiking. It may be a little bit of a rise in the acidification, but over time they adapt, and new corals will grow on top of the bleached corals. That's just a process that they go through, and it's been happening for millions of years. There are corals like in the Red Sea that have adapted to warmer temperatures than you have off the coast of Australia. So these corals are adaptable, and these processes that they're going through are natural.
So the people who study the Great Barrier Reef, they say that the corals are just fine. They're going through a regular cycle.
I think that there's two camps, and some scientists for sure think that there's a big problem, and it may even be the majority of them. But I know that there are some, like Craig Idso, for example. He is a scientist who believes that the Great Barrier Reef is doing just fine, and he says that these are natural processes that they happen on scales that surpass a human lifetime. So it's shocking to us when we see it. But if we have the perspective of these things happening over vast amounts of time, it's really not as alarming as people think.
Well, they're also saying that acid rain and the pH levels dropping in the ocean are causing this bleaching in the Great Barrier Reef. What would you say to people who are concerned about acidification of the oceans?
I mean, rain has a much is much more acidic than ocean water. I think ocean water is on average around an 8 on the pH scale, and rain is about 5.5.
Acid rain?
When you talk about acid rain, all rain, I mean, for as long as we know, it's been acid. Rain is more acidic than the ocean is, and pH is on a logarithmic scale. So if you're talking about rain being a 5.5, ocean water being an 8, then it's around 1,000 times more acidic than ocean water. So if we're talking about a change in the rain acidity from a 5.5 to like a 5.3, I mean, we're talking about is that going to make a huge difference in how much it can cause the ocean to change? These changes are not as big as people would have you believe, I think.
Okay, so is it human activity then that's causing the rain to acidify even that little bit?
I think it's possible that human activity has something to do with it, but as I've said before, it's just a piece of it. So, and it's cyclical. I mean, we have situations in the distant past where we've had volcanoes erupt, and those particulates in the atmosphere have caused the rain to be more acidic, and it didn't change the oceans to a point where it couldn't support life, or it was a problem for life then. So I don't see it being a problem for life now.
Okay, well, talking about ancient history, NASA has published 1 million years worth of CO2 data from the atmosphere, and it looks like the trend for the last century is pretty unmistakable. CO2 levels have risen sharply compared to the baseline over the last 1 million years. Is it because of us? Did we do it, or what's going on here?
Well, I think that, yeah, it is. It is because of us. I mean, the pre-industrial revolution level of CO2 in the atmosphere was somewhere around 200 parts per million. Now we're at 400 parts per million. So we have increased the amount of CO2, but remember, that's parts per million. So 400 parts per million. That's 0.04% of the atmosphere. So we have added CO2, but it's a negligible amount when you're talking about the entire amount of the atmosphere. And if you go further back than 1 million years, you'll get to points in Earth's history when there was a lot more CO2 in the atmosphere. There have been 1,000 or 2,000 parts per million in the distant past, and a lot of times those lines on the graph do not coincide with temperatures. So usually, what we find in the past is that rises in CO2 lag rises in temperature, which is a pretty good indicator that it can't be the cause.
Okay, we'll publish a link to that study about the CO2 levels that go back over 1 million years. How accurate do you think their methodology is compared to NASA's methods?
Anytime you go back into the distant past, you have to use proxy data. And those measurements are not going to be nearly as accurate. So it kind of gives you a picture, instead of an actual number. So, we can't, obviously NASA is going to be able to be much more accurate as far as the actual number, but we're not talking about accuracy versus inaccuracy here. We're talking about just the how much CO2 in general there was in the past. Whether it was 1,000 or 2,000, if it lags, if a rise in CO2 lags the temperature rise, then the amount doesn't matter as much. So we can see trends from these proxy data instead of getting an exact measurement.
So what you're saying is that the doubling in CO2 is unlikely to have caused the rise in temperature, because when we look back 2 million years, we see the temperature go up first, and then the carbon dioxide levels rise.
Yeah, I mean, it's what the alarmists will often say is that there's a compounding effect from CO2. So even if CO2 does lag temperature rise, then it creates this positive feedback to where it amplifies the warming. And then that is absolutely true. I think it's possible that there is an amplification of the warming because of human-caused rises in CO2. But again, if we're looking at since the Industrial Revolution, we're talking about a rise in temperature of maybe 1.7 degrees. And so at that point, you have to look and see, well, was the burning of fossil fuels that allowed us to increase our wealth and bring billions of people out of poverty and increase our standards of living, is that worth a portion of that 1.7 degrees? So it's not necessarily a question of whether the rise in CO2 that we have caused is actually, if that's true. The question is, was it worth it?
Well, last summer I went to California on vacation, and it seemed like the entire state was on fire. And a lot of people are blaming climate change for California's wildfires and drought. That seems like a pretty severe cost for 1.7 degrees of warming.
Yeah, I think it's because people really don't have a good understanding of fire ecology. California is a dry state. The ecosystems there they're meant to burn. They are fire adapted ecosystems. So like the chaparral, where these people, these millionaires build their homes, those ecosystems are meant to burn, and they're meant to burn on a much shorter time scale than they do now. So what we have is a situation where ecosystems that used to burn every 7 years naturally because of you get a lightning strike, and then there would be nothing to stop the fire until you get a weather event that puts the fire out. So you have fires that would burn for months at a time. Now we have fire departments. We have big planes that have fire retardant that they drop on fires. We have roads and infrastructure and all kinds of things that don't allow these natural fire ecology to run its course. And so you have a situation where all this fuel builds up that in the past, before European settlement, in the past that fuel would have been burnt up on a regular basis, and now it goes much past its normal burn interval, and it builds up. And then when a fire does start, you've got so much fuel that even the fire departments can't put it out. So it seems like these fires are caused by changes in climate, or some people attribute it to changes in climate, but it's really attributed to changes in human activity.
So you're saying that the big fires in California last year were a result of people just not letting the forests burn as often as they used to?
Correct, yes.
Oh, that's very interesting. Can we talk about ice cores for a minute and how they relate? You were talking about proxy data for CO2, and I was
Sure.
curious what kinds of proxies are used to collect the CO2 concentrations from the past.
Yeah, so proxy data is data that we can collect without having to be there. So if you're talking about something that happened 1,000 years ago or a million years ago, obviously nobody's there with a thermometer or something, an instrument to measure the CO2 level. So you have to use proxy data to get those measurements. So for instance, an ice core is going to contain some of this proxy data. So what you do is you drill a core in a glacier, and a glacier is formed by snow falling and compacting on top of itself. And over time, you have different layers of ice. And so the further you drill down into a glacier, the further in the past that a layer of ice was deposited. So some of these glaciers, you can go back many thousands of years, tens of thousands of years, and you can get a sample of what the atmosphere was like, because these ice cores contain small bubbles of air, and that air is like a time capsule from the atmosphere at the time it was deposited.
That sounds very useful. How accurate are these measurements from the ice cores? How do they compare to what we can do today when we just look at the atmosphere?
Well, I think the accuracy varies, depending on what you're measuring. So you can get a fairly accurate measure of the CO2 because it is just a little bubble of the atmosphere the way it was back then. You're going to have a harder time getting a reading of temperature from proxy data. Another way of getting proxy data is through tree rings. So you can You can core into a tree, and you can bring out a sample of the tree rings, and the tree rings are going to be similar to an ice core. The further into the tree you go, the further back in time you're going. And the tree rings, that's the way that the tree grows. A tree ring represents one season of growth. So the way that scientists try to get data that way is by seeing and measuring the width of these tree rings. So a narrow tree ring is going to represent less growth, and so they then try to extrapolate something like the precipitation at that time. So a narrow tree ring will represent a dry year, and a thicker tree ring will represent a wetter year. And they can do the same thing with temperature, although it's not as accurate with temperature. They can still, if it's a cooler year, the tree's not going to put on as much growth as in a warmer year.
Well, we don't have any trees that are 1 million years old. How useful is this data? How far back does it go?
Yeah, I'm not super familiar with how they get temperature data from that far back. I know that there are trees that are pretty old. There's some bristlecone pines that are thousands of years old. But as far as millions of years ago, I am not that familiar with how they get the temperature data from back then. I think that they can get the data of the atmospheric composition from ice cores. I think those do go back that far. Perhaps they can do something similar with mud cores from the seafloor. And they can determine the composition of the organisms that lived. And if there's an organism that they know could not survive certain temperatures, they can get an idea of what the temperature may have been.
So the trees can actually get us a few thousand years worth of climate data then?
Correct.
And then if that correlates well with the ice core data, then we just assume that the ice core data is good going back as far as that goes?
Yeah, I think that's a good way of looking at it.
Oh, that's very interesting. So you've put forward the possibility that human activity isn't necessarily the biggest factor in climate change. If that's true, what is causing the increase in temperature?
I think there's a lot of different factors that go into it. Solar radiation is probably the main one, and I've heard alarmists say that the solar radiation has not really changed much. But what has changed is not necessarily the amount of radiation that we get, but the angle at which the radiation is hitting the Earth. So there is something called Milankovitch cycles that describe how the Earth orbits the Sun. And a lot of people think that the Earth just orbits in a purely a round orbit, circular orbit. But actually, it's more of an elliptical orbit. And the way that the tilt of the Earth corresponds with the position around the Sun and how that changes can have a big effect. And this is how we're able to determine, looking at the past, we can see when ice ages occurred, and they do line up with these Milankovitch cycles of the Earth's orbit around the Sun.
So you think the Earth's orbit and the angle of the light coming in from the Sun has a big impact on the climate on the Earth?
Yeah, absolutely.
Well, that's very interesting. How important is it for us to continue to conduct climate science? I mean, if it's just the orbit of the Earth, why bother?
That's a good question. I think that we need to be studying everything. We need to continue studying everything, even things that we think that we know the answers to. So, science is the pursuit of knowledge, and we need to be continuing that. I just think that we have to make sure that we check our political bias at the door before we engage in a lot of this science.
In this interview that we've had today, you've basically pushed back pretty strong against several of the things that I've proposed as threats from climate change. If those aren't actual climate change threats, what threats do we face from rising temperatures and climate change?
No, I think that the threats are really minimal. Some people say that we're at risk of a sea level rise, and to me, the data shows that the sea levels have been rising for the past 10,000 years, since the end of the last ice age. And so actually 8,000 years ago, sea levels were rising much faster than they are now. So we're talking about a level that's at about 3 millimeters per year. So that translates to maybe 7 inches a decade. So, humans are adaptable. If we are experiencing that kind of sea level rise, then it's not going to happen overnight. So we can adapt to it, and we can change. But again, it's been happening for a long time. So it's not necessarily because of recent warming.
Well, let me give you one last little piece of pushback. The
Sure.
activists up in Greenland were talking about how the hunters can't get out on the ice anymore because it's retreating, and it's causing starvation among the polar bears, and the seals are getting overpopulated. Isn't that a risk from climate change?
Well, the data actually shows that polar bear populations are stable or rising. So that's really not a threat from climate change. And as far as Greenland hunters, I think that their ancestors went through times when they weren't able to hunt as effectively on the ice, because there were times in the past when we had a cycle like this where it was warmer and there was no ice. So, they adapted, they changed, and I think it's the same today.
Well, you got me. I've thrown all the questions that I've got at you, and you've pushed back on all of them, and I don't have any more rebuttals for you. So if people want to find you and push back personally, how should they go about finding you online?
Yeah, sure. Just check me out on Twitter. Search my name, Jonathan Grassmick, or search me on Facebook and find me there.
All right, and I'm Edward Hofer with PolitiPeeps. If you enjoyed this video, please like, share, and subscribe, and ring the bell to get notifications for new content.